So in this video, we're going to be interpreting a quadratic function, but for this one, we will be given the graph. So this first one says, a rock is thrown into a lake from the top of a cliff. The relationship between the height in feet of the rock and time in seconds after the rock is thrown is illustrated in the graph below. And so again, over here, this is going to be your height. Down here is time. First question is, I want to know what the initial height of the rock is. So I want to know how high the rock is at when it is first thrown. And so if you remember from that first video, the initial starting point, anything like that, it's always going to be your y-intercept where it starts right over here. And so I want to see, okay, where does it start? It starts here, and that's at 128 feet. Okay, the next question says, how high is the rock after 3 seconds? So again, to find out how high it is, I need to go to 3 seconds on my x-axis. Let's say that's right here. And I'm going to see what point that is associated with. So I can do a dotted line. I see that's this point right here. Well, I have to look to the left to see, okay, well, how many feet is that at? And I see that is at 80 feet. So after 3 seconds, the rock will be 80 feet high. Next one, I want to know what the maximum height is, and that is always going to be at the vertex. And so I'm looking to see what's the highest this graph goes. And I see that's at this point. And since I'm wanting to know the height, I want to know what it's at for my y value. My x value is seconds, so I see that in 1 second it's going to be at the highest height. But to see what that maximum height is, I need to look at the y value, and that's at 144. Then the last question, I want to know how long the rock is in the air. So I want to know, when does it end up reaching the ground? And so remember back to that first video, that's going to be your second x-intercept here at the very end of your graph. And so I see that is right here, which is at 4 seconds. Okay, so this next one says a golf ball is hit from the shoreline of a water hazard. The graph below illustrates the relationship between the height of the golf ball and the distance from the shoreline. First question is, what is the height of the golf ball when it is 18 feet from the shoreline? So this graph ended up looking a little bit different. I really need to read what my x and y axis is. Here, my x-axis is my distance from the shore, where my y-axis is the height. And so for this one, I want to know what the height of the golf ball is when it's 18 feet from the shoreline. So I want to go to 18 feet on my x-axis here, which is right here, and go up to the graph. Let's see, that's somewhere between 3 and 4, so I'm going to say it was about 3.5 feet. Okay, the second question says, if the distance from the shoreline is 10 feet, how high is the golf ball? So now I want to go to 10 feet from the shoreline and see what that's at. And I see that's actually at my vertex here. And if I look to the left, I see that's at 10 feet. Last question says, what is the total horizontal distance the golf ball traveled through the air? So I want to know, how far did this golf ball end up being hit? And so that's really similar to this last question here of how long it's in the air. I want to see how far it traveled, and that's going to be at the very end of my graph here, and I see that's at 20 feet.